Good morning. This lecture is part 2 of beam and frame structure, which is going to talk about how to draw shear force and bending moment diagrams. For part 1, which is determining internal beam force, you can refer to my previous video. Please subscribe to my channel, which is a huge support for me to continue making video. Thank you. Let's start. The slope of the shear diagram at each point is equal to the load intensity at each point. To convert it into a formula, the slope of the shear diagram at each point is dV over dx, which is equal to W, and W depend on x. It means W of x is the load intensity at each point. Therefore, the total change of shear is equal to the integration of W of x. Let's start with an example. For a beam having a 20 kN per m loading intensity, W is equal to 20, which its value is independent of x. It means no matter at which point of the beam, its loading intensity is always 20 kN per m, and therefore, the slope of the shear force diagram is always negative 20. If the load intensity is increased linearly like this, W is dependent on x. In this example, W is equal to 20x. Before drawing the shear force diagram, the support reaction is needed to find first. In this case, support A is equal to 3.33 kN, and support B is equal to 6.77 kN. At x equals 0, an upward reaction force of 3.33 kN. The load intensity W then equal to 20x, which the slope of the shear force diagram is negative 20x. When x gets larger, the slope will decrease deeper, and it is in a parabola shape. The total change in shear would be integration of W of x. Let's integrate the function of W with respect to x. It is negative 20 times square of x, which x equals 1 and divided by 2. Then plus 20 times square of x, which x equals 0 and divided by 2. Its value is negative 10 kN within x equals 0 m to x equals 1 m. 3.33 minus 10 equal to negative 6.77 kN. At x equals 1 m, an upward reaction force of 677 kN applied. The shear force diagram is completed. Then let's go to the bending moment diagram. The slope of the bending moment diagram at each point is equal to the shear at each point. To convert it into a formula, the slope of the bending moment diagram at each point is dm over dx, which is equal to v of x. And v of x is the shear at each point. Therefore, the total change of moment is equal to the integration of v of x. Let's start with an example. A 20 kN point load at the midpoint of a beam. Before drawing the bending moment diagram, the support reaction is needed to find first. In this case, support A is equal to 10 kN, and support B is equal to 10 kN. Then, we need to find the load intensity, which W equals 20 kN at the midpoint of the beam. Then, we can draw the shear force diagram. At x equals 0, support A has an upward force of 10 kN. Then, there is no load intensity, which means the slope is 0 until at the midpoint of the beam. That there is a 20 kN downward force. Then, it continues at 0 slope until at support B, that is a 10 kN upward force. Finally, we can start draw the bending moment diagram. The slope of the bending moment diagram at each point is equal to the shear at each point. At the first half of the beam, shear force at each point is 10, which means the slope of bending moment diagram at first half is 10. And after that, its shear force at each point is minus 10, which means the slope of bending moment diagram after the first half is minus 10. The maximum moment would be at midpoint, which is the total change of moment at first half. And it is the integration of v of x. Thank you for watching. Please subscribe to my channel, which is a huge support for me to continue making video. Thank you.